3.53, here it says determine the empirical and molecular formulas for each of the following. First step, assume a 100 gram sample, so 92.3 grams of carbon and 7.7 grams of hydrogen. And then we have a molar mass down here at the end that we'll use when we'll do to the molecular formula. Step number 2, convert to moles. So in 1 mole of carbon there are 12 grams, and in 1 mole of hydrogen there is 1 gram. Where did I get those numbers? I got them off of the periodic table. Carbon is 12, hydrogen is 1 right here. After I've converted to moles, then I want to take these moles and I want to divide by the smallest. So my 92 divided by 12 gives me 7.685, and my 7.7 times 1 divided by 1 gives me 7.7. Look at that, we're going to be dividing by 7.7 for both of them, or 7.68, which give me C1H1 as my empirical formula. It does tell me that my molar mass is 104, so add this one up. This one is 12 plus 1 from the periodic table, so 13 times some number x is equal to 104. So when you take that numbers and solve for x, you get x equal to 8, which means that number gets multiplied by each one of these subscripts to give you the molecular formula. So C8H8 is my molecular formula for 53A. 53B, this is chapter 3, 53, on the next page. Caffeine, a stimulant, contains 49.5, and assume a 100 gram sample, 5.15 grams of hydrogen, and 28.9 grams of nitrogen, and 16.5 grams of oxygen. Convert to moles. Carbon is 12 grams in 1 mole, hydrogen is 1 gram in 1 mole, nitrogen is 14 grams in 1 mole, and oxygen is 16 grams in 1 mole. I got each of these numbers, 12, 1, 14, and 16, from the periodic table from looking up their molar masses. Alright, when I divide these then, I get 4.12 moles of carbon, 5.11 grams of hydrogen, or 5.15. I get 2.06, and then I get 1.03 for my moles of oxygen. Now I divide by the smallest, so I will divide each one of these by 1.03, and then when I do that, I end up with 1 oxygen, I end up with 2 nitrogens, I end up with 5 hydrogens, and I end up with 4 carbons. And there is my empirical formula. Now it says the formula weight is 195 grams per mole. So 195 has to equal what this formula mass is times some number x. So I add this up on the periodic table, 4 carbons plus 5 hydrogens plus 2 nitrogens plus 1 oxygen, and I get 97. So 97 times some number x is equal to the formula weight right here. Divide both sides by 97. I end up with x equaling 2. And so that means I need to double each one of these numbers. So O2, N4, H10, C8. I have to multiply each one of these subscripts by this number to get the molecular formula. All right, last one, 53C. Monosodium glutamate, assume a 100 gram sample, 35.51 grams of carbon, 4.77 grams of hydrogen, 37.85 grams of oxygen, and 8.29 grams of nitrogen, and 13.60 grams of sodium. Convert each to moles. In 1 mole there's 12 grams, in 1 mole there's 1 grams, in 1 mole there's 16 grams, in 1 mole there are 14 grams, in 1 mole there are 23 grams. Bang, 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 bang. Do the math on your calculator, and we end up with carbon being 2.96, hydrogen being 4.77, oxygen being 2.37, nitrogen being 0.592, and sodium being 0.592. divide by the smallest. We take each one of these and divide it by 0.592. We end up with sodium being 1, nitrogen being 1, and then we end up with let's see, oxygen being 4 and hydrogen being 8 when we divide this, and then the carbon being 5, I believe, pretty close to 5. Okay, now we have to check if this matches the 169. So you add this guy up on the periodic table. When you add that up on the periodic table, the formula weight is 169, and that equals the 169 times X. That means that this empirical formula is also the molecular formula.